colossal works, the biggest things humanity has ever tried to build. 240 meters beneath the surface of the sea, a bullet train is slowing down. Above it sit the cold waters of one of the most dangerous straits in Japan. This train was built to move at 320 kilometers an hour. Down here, it is limited to 160. And the reason why is the whole story. This is the Seikan Tunnel. For decades, it was the longest undersea tunnel on Earth. It was meant to be Japan's triumph over the sea, a permanent link between two of its main islands, and the road that would finally carry high-speed rail to the north. That was the promise. What actually happened is stranger, and a lot more human. To understand the ambition, you have to go back to a single, terrible night. In September of 1954, a powerful typhoon tore across the Tsugaru Strait, the stretch of water separating the island of Honshu from the northern island of Hokkaido. At the time, the only way across was by ferry. That night, 5 ferries were caught in the storm. One of them was the Toyamaru. When the typhoon was over, more than 1,400 people were dead. It remains one of the worst maritime disasters in Japanese history, and it changed the way the country thought about that strip of water. The sea had proven, again, that it could not be trusted. Japan decided it needed a link that a storm could never touch. Not a bridge, exposed to the wind. Something deeper. Something the weather could never reach. The plan was staggering. Engineers would dig a railway tunnel clean under the strait, through the seabed itself. When it was finished, the Seikan Tunnel would stretch almost 54 kilometers from end to end. 23 of those kilometers would run beneath the open sea, at the open sea. At its lowest point, the track would sit about 100 meters below the seabed and roughly 240 meters below the waves. Nothing like it had ever been attempted. To dig it, crews first bored a smaller pilot tunnel to map the rock ahead. Then a service tunnel. Then, finally, the main bore for the trains. 3 parallel tunnels, crawling toward each other from both islands, deep under a moving sea. On paper, it was one of the boldest pieces of engineering the world had ever seen. The problem was the ground it had to pass through. The rock under the Tsugaru Strait is not solid granite. It is a broken, fractured mess of volcanic stone cut through with fault lines and soft zones, and all of it soaked in enormous water. Digging through it was less like tunneling and more like trying to hold back the ocean with your hands. And on the 4th of May, 1976, the ocean won. A section of the works hit a soft fault zone and the sea broke in. Water poured into the tunnel, faster than the pumps could handle, tens of tons a minute, and floods and kilometers of hard-won excavation. Crews scrambled to seal it off before the project drowns. It took months. They led them to pump the tunnel dry and repair the damage. It was not the first flood, and it would not be the last. Each one asked the same question. Was this tunnel even possible? The answer came at a staggering cost, and it arrived on 3 fronts. The first was money. The Seikan Tunnel was originally budgeted as an expensive but manageable national project. By the time it was finished, the total cost had reached around $7 billion. That was roughly 12 times the original estimate. 12 times. The overruns came from the ground itself. To get through that fractured, waterlogged rock, engineers pioneered a punishing technique. Ahead of the digging, they drilled holes and injected cement grout into the rock, again and again, sealing the fractures before they could leak. Worked, but it was brutally slow. The tunnel advanced through some zones at a crawl, meter by meter, sealing as it went. Which brings us to the second front. The engineering was not just expensive, it was deadly. Across the full construction, the tunnel employed as many as 3,000 workers at a time. Over the years of digging, 34 of them were killed. Cave-ins, floods, accidents in the dark, far out under the sea. Every kilometer of that tunnel was paid for in lives, not just yen. And the digging simply would not end. Surveying had started back in the 1960s. Full construction ran through the 70s and deep into the 80s. In total, from the first serious work to the first train, the Seikan Tunnel took around a quarter of a century to complete. A generation of engineers spent their entire careers underneath that strait. Then came the third front, And this is the one that hurt: politics and timing. While the tunnel was being dug, the organization building it was falling apart. Japan's national railway had been drowning in debt for years. In 1987, just 1 year before the tunnel opened, that national railway was broken up and privatized. The institution that dreamed up the tunnel barely survived to see it finished. But the deeper problem was the world above the tunnel. It had moved on. When the Seikan Tunnel was conceived in the shadow of a ferry disaster, crossing the strait was slow and dangerous. By the time it finally opened in 1988, that was no longer true. Cheap, fast, domestic flights had appeared, and for a traveler heading from Tokyo to the north, a plane was simply faster. So the tunnel opened to a strange, quiet problem. It was a monumental achievement that very few passengers actually needed. For years, the trains that ran through it were ordinary, slower services. The one thing that might have justified the whole project, a true high-speed line to Hokkaido, did not run through it at all. The bullet train, the reason the tunnel made sense, simply was not there yet. For nearly 3 decades, the greatest undersea tunnel on Earth waited for the trains it was built for, and then in 2016 they finally came. The Hokkaido Shinkansen opened for the Convai time learned, and for the first time a bullet train ran under the sea through the Seikan Tunnel. On paper, the dream was complete. In practice, it came with a catch, because the tunnel is still shared. Around 50 freight trains use it every single day, and those slower, narrow-gauge trains cannot be pushed aside. That sharing is why the bullet train slows down. Shinkansen speed pushes a wall of air ahead of it. In the tight space of the tunnel, that shockwave could slam into an oncoming freight train and destabilize it. So inside the Seikan Tunnel, the fastest trains in Japan are held to 160 kilometers an hour. The tunnel that was meant to unleash high-speed rail is the one place it has to hold back. And the passengers still have not really come. As of reporting in the mid-2020s, around 90% of people traveling between Tokyo and Hokkaido still fly. The Tokyo to Sapporo air route is one of the busiest on the planet. The Shinkansen will only truly compete when the line reaches Sapporo itself, and that extension has slipped. Current projections put it near the end of the 2030s. So what is the Seikan Tunnel, really? It is not the failure its critics once predicted. It carries those 50 freight trains a day, quietly moving a huge share of the goods that keep northern Japan supplied, in all weather. No matter what the strait is doing above it. It became an artery. It is not the one it was designed to be. It was built to move people away from a deadly sea. And instead, it ended up moving cargo, a monument to an ambition that history quietly overtook, still doing honest work 240 meters down. Which raises a harder question. When a nation spends a generation and 34 lives to beat the sea, and the world moves on before the work is done, was it a failure? Or just early? If this blew your mind, hit that like button and subscribe for more megastructures, and tell me in the comments which one I should cover next. Thanks for watching, and I'll see you in the next one.